Another example here from the book. A manufacturer of window frames knows from long experience that 5% of the production will have some type of minor defect that will require an adjustment. What is the probability that in a sample of 20 wire frames, none will need adjustment, at least one will need adjustment, and more than two will need adjustment? So first thing, which type of probability? So right away we should recognize this as binomial. We have two options, needs adjustment, doesn't. We're doing 20, so n is 20, and one needing adjustment doesn't affect the other, so it's independent. So all three of our criteria for binomial are satisfied, so that's how we're going to proceed. Now we can say, well, probably none will need adjustment, so that's the probability of x equaling 0, and we know n here is going to be 20. Probability of success is going to equal 0.05. Now we just need to put it on the calculator and get our answer. So we go to distributions. We're using PDF because we want the probability that none will, exactly none. Let's try that again. Probability, so PDF because it's exact here, so 20 trials, 0.05 for success. Probability that none will need adjustment is right there. So 0.358. That's the probability that none of the windows will be defective out of a batch of 20. Now it says, what is the probability at least one? Well, if you think about it, probability of x at least 1 means greater than or equal to 1, or it's 1 minus the probability of x being 0. So we can do this directly. 1 minus 0.358, and we'll just stick it on our calculator here. And we get 0.642. So this is the probability at least 1, which is the complement of none. The final one, more than 2 will need adjustment. So the probability of x being greater than 2. And our calculator, we can use CDF, but that adds from 0 up. So we need to take 1 minus, and what's in here is the probability of 0, because that can't be, the probability of 1, because that can't be, and also we're not including 2 here. So we're taking away the probability of 0, 1, or 2, and we're left with the probability of the rest. On our calculator, that's going to be 1 minus, and this is a binomial CDF here. We want to cumulatively get the probability from 0, 1, and 2 and add them together, and let the calculator do that. And in these brackets, we're going to put 20 trials, 0.05 success rate, and up to 2 we want to include cumulatively. And so we can put that all together. 1 minus distribution, cumulative CDF this time, binomial CDF. Trials is 20.05 for the value of the probability of success. 2 we want to subtract from, and we find that the probability of more than 2 is 0.75 or 7.5%. And that's the end of that example.